Continuing on with our introduction to the object-oriented paradigm, let's talk about why the object-oriented paradigm is considered to be a good thing, or at least the kinds of things people were hoping to get out of it. People were hoping to get at least three big things. Prior to the object-oriented paradigm, the imperative and procedural paradigm was the primary way that people wrote software. And one of the problems with that is that all program elements shared the same memory space, which meant that once you started to have a large project, people were accidentally stepping on other people's data. So I put some value in X, and then I go to get X later on, and I know what that value is because I put it there, but it turns out somebody else wrote over my data, and now I have a different value than I thought I did, and now all my computations are incorrect. And it's very difficult to debug. It's very difficult to figure out what went wrong. It's very difficult to keep track of it all. But if you put all that data inside of these objects, that's called data encapsulation. And the idea is only that object is the thing that gets to touch that specific piece of data. And when you're creating your objects, you should be very protective and very jealous of your data. Don't let anybody touch your data without your consent. So data encapsulation. And that's the big one. It actually worked. It's very successful. People were hoping that would work, and it works. So you encapsulate the data inside, and whoever wrote the class or the design for the object gets to determine how people can interact with the data that's in there and how they can change it and put rules up so you can't change it in a crazy way. If you're trying to do an aircraft object, it's probably a good idea to have allowable aircraft altitude to be sea level up to, say, 60 or 80,000 feet. Probably a bad idea to let people have airplanes at negative 10,000 feet. Or positive 10 million feet. And if you're allowing people to have access to your data in ways that you control, you can take care of that. You can make sure that if people try to, or other pieces of software, try to give you bad data values, you can block that. You encapsulate the data, you protect the data. This is the most important component that object-oriented paradigm gives us. Remember that, right? So remember that for your job interviews. Hey, what's good about object-oriented? Data encapsulation. It should just roll right off your tongue. The second thing people were hoping for was code reuse. Ideally what people thought would happen is over time you would have a collection of objects like in a library, and then you can just, rather than write a piece of software, you can just pull out these objects and stitch them together and you've got software. There's actually a paradigm called component-based software design that attempts to do just that. There's a reason why you haven't heard of that necessarily. There's a reason why that's not used in industry. There's a reason why we don't have a course on component-based software design, because it really hasn't panned out very much. So from that aspect, code reuse wasn't great. But there's one aspect where code reuse is really working well, and that's through this inheritance feature that we talked about last time. So you can create a generic object and then you can extend it. And when we get into graphics, you'll see that it's a core part of how Java does graphics. They give you all of these basic elements like circles and rectangles and panes and lines and text and things like that. And then you take their generic version and you adapt it to your graphical needs. So the code reuse was somewhat successful. And the third big thing everybody hoped was software understanding, because they said, okay, if we chunk everything up into objects, the objects are smaller, they're more comprehensible, and we can think about how the objects work together, and we will have, finally, understanding of our software. Again, this was a problem before the object-oriented paradigm came along. People were developing larger and larger pieces of software. There were multiple attempts to try to organize it. Basically structured programming and basically trying to break the code into blocks, block-based kind of programming. And nobody knew what the software was doing, and nobody understood the software, and nobody knew when it worked, why it worked, and when it failed, why it failed. It was very confusing. And so the object-oriented paradigm was promising that we would have an ability to get better understanding of the software we were building. And this really wasn't successful at all. I mean, it's kind of still the same thing. When large pieces of object-oriented software work, nobody knows why. When it doesn't work, nobody knows why. I mean, that's a bit of an exaggeration, but not that much. Software understanding is an intrinsically hard problem, and I don't know if we'll ever solve it. It's an intrinsically hard problem. It's harder than other forms of engineering. With other forms of engineering, you can build a part and you can hold it in your hand. You can take that part and match it up with other parts, and they either fit or they don't. And if it doesn't fit, you know why. With software, you can't do that. It's just much harder. So the three things we were hoping for was data encapsulation, code reuse, and software understanding. Data encapsulation worked great. Code reuse through the inheritance features works pretty well. Software understanding, we still don't understand software very well. It's an intrinsically difficult problem. Okay, let me talk a little bit about some notation. So when we start to do Java in the next module, we'll start looking at Java software and how to program in Java. Again, not because this is the Java class, we just happen to use Java as an object-oriented example of a programming language. Naming conventions, first of all. Class names start with a capital letter. That's how you know they're class names. Animal, sheep, dog, terrain, capital names. Attribute names start with lowercase and then use camel hump notation. What camel hump notation means is if you have a variable that's composed of several words or shortening versions of words, then each new word starts with a capital letter. But the first one starts with lowercase. So I have X location with the lowercase x capital L, Y location lowercase y capital L, max speed lowercase m capital S. One of the things that's different in Java and in object-oriented programming in general, but in Java in particular, I think, is to use relatively long and descriptive names for your attributes. Don't just say X and Y. It's X location and Y location. That way you can differentiate it from X speed, Y speed, and X acceleration, Y acceleration. Don't just say R for radius. It's radius. Go ahead, spell it out. It's okay. Your IDEs, your software developer tools like Eclipse will help you with that, so that once you enter in a variable name once and you start to type it, it will autofill for you. So it's not like you have to do, oh my gosh, I have to do all this extra typing. No, you don't really. Variables created locally to a method are named like attributes. Now remember, attributes tell you the state of the class or the state of the object, and variables are what we're going to call items that are created locally inside of methods. Constant values are all caps. Pi, speed of light, that's not speed of flight, it's speed of light, color, that kind of thing. In addition to that, every class you make and every attribute and every method, you can provide what's called a visibility modifier, and I'm going to strongly encourage you to do this. And what the visibility modifier does is it determines who can see that thing. Remember, data encapsulation, this was important. So you can either set your attributes to private or public or protected, and always use private. It's that easy. Always use private. When you create a method, remember a method is the OO word for function. When you create a method, you can set it as private or public or protected. Private means nobody can see it. Public means everybody can see it. Protected is somewhere in between. If you leave that modifier off, which you are allowed to do, your program will compile and run. If you do that, then we don't know what the visibility is. Different vendors interpret that differently, so you never want to do that. Make all your attributes private. Your methods, if you need an external object to use that method, if you're basically you're providing a service, right? The method is doing a job for somebody else, make that method public so that external entities, external objects can use that method. Protected is rarely used. So set all your attributes as private. That's what data encapsulation is all about. Most methods will be public. Most methods. Again, we're going to talk a lot about this as we go through the course. The brackets, Java uses three and a half kinds of brackets. There's three. There's a fourth version that gets sometimes used, but I'm not going to cover it here yet. Curly brackets, always bound blocks of program. So we'll talk about that. And again, the next lecture will have examples of this stuff. Curly brackets, one of the cool things about Java, curly brackets always bound blocks of programs. So when you're doing if then else structures, if you're doing for loops, you bound the for loop using curly brackets. If then else structures, you bound the true and the false sections with curly brackets. The class definition itself is bounded with curly brackets. So that's always giving you a boundary of code. Parentheses are always used for method input. So in the previous case we had move and I put parentheses there. What that means, because the parentheses were empty, is that the move method takes no input. And square brackets are used for arrays, which I believe all of you have seen in a previous class, but I'm going to pretend you didn't in a week or so, and we'll go through arrays again for Java. In addition, Java requires that you declare attributes with their name and type. Now, if you took the C or the C++ class, this is not new to you. If you came from MATLAB or other classes, this may be new to you. MATLAB doesn't require that you declare or tell the computer about an attribute or a variable. You can just start using it. You have to declare the attributes. So before you can use it, you actually have to say, hey, I'm going to use variable x max. I'm going to use variable x location or attribute x location. In addition to the name, you have to supply the data type. So we'll talk about data types again at great length. But basically, you're either going to use an integer, you say int, you're going to use a numeric non-integer value, you say double, a single character, char, that's usually pronounced char, a sequence of characters, a string. So for examples from the sheepdog game, we would say private int xspeed. That means that the xspeed attribute is private. Nobody outside the object has access to it, and it's an integer value. Or we could say public double xspeed. Now everybody outside the object can see it. It's double, so it's numeric, but it's not an integer, and it's still named xspeed. Or we could say private int max speed with capital letters and set it equal to 20, and that's a constant. We wouldn't have we wouldn't want anyone to change that. Technically, the way I wrote it, it can be changed, but we'll get into that later. For the movement method, public int move. So even with methods, you have to say what their return type is. So public, everybody can see it. Move is its name. Empty parentheses, so it isn't taking in any input. And then inside the curly brackets, you would describe what the move method actually does. So we have public, move, I'm going to come back to that in a second, move, and then inside the curly brackets, you would put all the code you needed for the move method. So what's this int, public int move? Well, remember, int means integer. What it means is if you call the move method, it's going to give you back an integer. So public int move means public, everybody can see it. It's returning an integer, and then its name is move. Because the parentheses are empty, it doesn't take any input, and then the curly brackets, whatever you put inside there is the actual code for that method. Now what's this void down here? Public void move. That's what you say. Well, let's see. If I return an integer, it's int. If I return a double, it's double. If I return a string, it's string. What if I don't return anything at all? What if I just change some attribute values, but I never return anything? That's void. So, again. Okay, so we'll continue with this with the next lecture, and now we'll start to move into coding examples from here.